Gold. I think we all know it's phenomenally expensive. A piece of gold about the size of two 2p's would cost about £1,000, which is obviously considerably more than the copper, which must cost less than the 4p that's printed on it. So it seems kind of surprising when you get into it, just how much gold is around us. My phone is practically paved in gold. Have a look at my SIM card, that's gold. Have a look at the SIM card contacts, they're gold. It's not a particularly flash phone even. Battery contacts, gold. Other side, gold. So why is it that even though gold costs £1,000 an ounce, we're still using it willy-nilly in all our electronics? Well, it's kind of the reason why it's used for jewellery as well. Here's some gold that I made earlier, or at least extracted from electronics. And even though it's a couple of weeks old now, it's still completely shiny. It has not tarnished in any way. And that is really the secret of gold's success. It doesn't react with the air around it. These copper coins, they were pretty shiny when they were made, and over the years they've kind of reacted with the air around it, and now you've got some copper oxide on there and they look pretty dull. But gold doesn't do that. And in fact, it's not just the air around it doesn't react with, it hardly reacts chemically with anything at all. Most acids, drop it in, gold is completely oblivious to it. And it's down to the atomic structure of gold. Its nucleus has such a strong positive charge, it's a relatively big nucleus, that it keeps a tight hold on all the electrons around it. And those electrons are therefore very hard to get ripped off by something that wants to attack it chemically. Now I'm going to chance my arm here slightly. I've got some concentrated nitric acid. This is extremely vicious stuff. Almost any metal, you drop it in here, it's going to start reacting. But so confident am I that I've made gold that I'm going to drop some of my gold in it, and hopefully, if I'm right, it will not react at all. Right. Concentrated nitric acid. Nasty. Nasty to me, and nasty to almost everything that isn't gold. Concentrated nitric acid, just to slide this in there. It's going off like a vitamin pill. That's pretty intense. You can see that kind of copper nitrate green coming off it. The copper nucleus is just not able to hold on to all its electrons, and the hydrogen in that nitric acid is just pulling them off. Copper's just getting completely destroyed. There's a lot of poisonous brown gas too. I'm going to tip some of that concentrated nitric acid in there now and drop the gold that I went to so much trouble to make. Now if this gold fizzes and disappears, I will be crushed on camera. There's my gold that I went to all the trouble to extract. Now hopefully when I drop that into the acid, the gold atoms will hold on to all their electrons, they won't react with anything, and that will stay as a beautiful shiny little nugget. Oh, look at that! That's good as gold. That's astonishing. That is not doing anything at all. And it's this unreactivity that makes it such a good electrical connector, because it's a metal. It conducts electricity brilliantly, like copper does, but unlike copper, it doesn't react with its environment. It stays as pure gold. So the connection that you make between your SIM card and your phone today is as good as the connection tomorrow, next week, and in 6 months' time, right the way through to your upgrade and beyond.